Welcome to video 4.4d, the last proof with the equidistance theorem. All right, here we go, example 4. So given that ABCDE is equilateral and equiangular, so all sides congruent, all angles congruent, also F is the midpoint of segment AE, prove that FC is the perpendicular bisector of BD. So now what I'm going to do is, just in case you're getting confused with who's bisecting who, I'm going to highlight those in different colors just to help your brain out. So prove that FC is the perpendicular bisector of BD. So that means, for that green thing, I want to get some equidistance lengths to the endpoints of what I'm bisecting. Okay, so I've got to get some equidistant lengths. Well, just to mark up, right away, point C is equidistant to those two endpoints because we're equilateral. So now the whole proof hinges on getting point F to be equidistant to those. Okay, well, I don't even see any segments drawn from point F to those, so why don't we draw them? Okay, so I will draw them in. Your book does it in dashes. I'll just do it so you know that I drew it in. And then, if I can somehow get those two sides to be congruent, game over. I'll have my 2 points. Okay, I've already got point C, and then I'll have point F. All right, so now how to get those? Oh, it looks like a triangle's being formed. So it looks like I'm having a triangle over here and a triangle over here. So if I could get those two triangles congruent, then I could get those parts congruent, game over. Now let's see how I can get those two triangles congruent. Again, this is how my brain works for the proofs. I kind of go in reverse. All right. Oh, well, I'm going to get this side congruent to that side, equilateral. This angle to that angle, equiangular. Oh, they said F is the midpoint. So I'll have that. Oh, side, angle, side. I've got two sassy triangles. Okay. And then once I get that, I got parts. Now it's just a matter of writing it down. I know exactly where I'm headed. Please invest time in what I just did there. Okay, so I'll get the triangles in SAS order, and then I'll get the points at some point. So let's try to get the triangles first. So I better say that I'm equilateral. So A, B, C, D, E is equilateral, given. From that, I got AB to ED. AB congruent to ED if equilateral, then sides congruent. Okay, and I'm going to take credit for a side. Ooh, I'm going to say I'm equiangular. ABCDE is equiangular, given. From that, I got angle A to E. I could just use one letter. There's no confusion. Angle E, A congruent to angle E if equiangular, then angles congruent. And then for that side, I'll go with the midpoint and then get the two congruences. F is midpoint of AE given. Then I'll go AF is congruent to EF if midpoint, then two congruent segments. So I now have my triangles congruent by SAS. I can get those equidistant points that I cared about. So now I could say, well, I gotta get the triangles first. Triangle, we'll call it BFA, is congruent to triangle DFE by SAS. Then I can do CPCTC. BF is congruent to DF. Again, first two letters to first two letters, I like that. By CPCTC. I'm going to take credit for an equidistant point. I could have said AB is congruent to ED if equilateral inside is congruent. I could have also at the same time done BC to CD. So I think I'll stick that one up there. So BC is congruent to DC, the same reasoning, and I'm going to take point credit for that for equidistance. Okay, so now I've got that equidistant point, that equidistant point. Now I can say perpendicular. FC, perpendicular bisector of BD. If kite thing, then perpendicular bisector thing. Whew. So there you have it, the last proof on the equidistant theorem.